This question is about Proteus and Arduino. We are going to design this project called the temperature recording and display system. As electronic technician, you are requested to implement a project of recording and display with the LCD and the serial monitor, a room temperature values, finally switching on a DC fans if and only if the temperature research reaches to 38 degrees Celsius. Being initialize serial communication at 1200 bandwidth. The title in the LCD should be displayed as temperature recording and display system. What we have to do is about A and B and C. We have proposed to design a circuit on Proteus. Propose the code for the above project in Arduino. Simulate with Proteus software design circuit. We have to make our session today depending to that question. I think everybody knows about design circuit and the code for Arduino. We appreciate you to attend this session today, and before we start, we tell you to subscribe for more. Take your time, make a like and make subscribe to our YouTube channel. Thank you. Let we start our session today. A Proteus depends on our project, so you click on a new project and you create your project. You come and write your names of your project. You comes on the notepad and take these our names of project and comes paste to a Proteus and you take a next. So you wait for a little time to take our compiler and we start to design our Proteus. First of all, we need microcontroller. Our microcontroller called Arduino. We need Arduino called Uno. You click on the Uno and you drag your Uno and paste to your compiler. So we need a fan. You comes here, you write a fan. You get your fan. This is a fan. You comes and paste your fan here. We need the LED as indicator. You write animation. Your animations, like we use yellow, okay, and you come paste here your red. We need the LCD that used to display our temperatures and our project title. You comes in different, we have a different LCD. You see, we need the LCD. Just let we take this. I think we can use this. Or like that. Can use LCD. you come and drag paste on here. We need another component. We need the virtual terminal. That is terminal. It's used to display our temperature. We need RM, 35. You got RM here, and you comes and paste. You see, okay. We need a potentiometer, like is this, comes and drop here. So we have our design. We are going to join our component to our Arduino. So here we have another component. We miss like the power to supply LEDM. So we come to search to our power. You come here to get a power. Comes and drag your power here to supply our LM, and you come to join this LM and the potentiometer, and you come here, take and ground. You put your ground here, and you come and paste your ground on a Proteus, and you join. So we continue to join our Proteus. You see, here we have LCD. We are going to join LCD. Here we have VCC, VDD, VEE, LCE, and read and write, and enable. We have to join those pins to their direction. Though you know the VCC is joined to the ground. You know that. No, you wait, gato, wait, and you comes here, take the ground, you drag and you put here. So you see, we have a VCC is connected to ground now. That is VDD is the pins connected to the power. You comes and connect to the power. Our VDD of LCD is connected to the power. Now we are going to connect this VEE. The VEE is connected to the potentiometer that is used as a brightness, as variations. You see, that is VEE now is connected. We are going to connect this RS. We are going to connect RS. RS is a pins connected to the Arduino pins. You comes to RS and you comes and drag your your terminal, your pins to 13. Like for example, we use a 13, or like we can use a 12. Let's we use a 12. No. Let's we use a 12. Yeah, we can use a 12. Yeah, you see, our LS is connected to 12. We have to connect read and write to the ground. Take your pins and comes connected to our ground. So our pins automatically connected to our ground, and we have to connect our enable to our Arduino. Let's we use 11, and we connect our D to Arduino, like we use 5 on our Arduino, and we take those ones to our Arduino. Let's we use like 4, and we use this. Come here and we use a 3, and we take use 2, and we connect our virtual terminal. Our virtual terminal, we have 2 times we connect it to our Arduino. We have a receiver and we have a transmitter. Our receiver comes connected to 1. You see, 1 is a transmitter is connected. You see, if you have a receiver here, you connect your receiver to transmitter on Arduino, and if you have a transmitter here, you connect it to receiver on Arduino. So we have keep going to connect our RAID and our fans. You come here on, you take ground, come and drag here and connect our fan to our ground, and take RAID, connect to our ground, and you take RAID, go to connected to our Arduino. Let's we take like 13, and we take our fans, go and connected to like 8. So for us, we finish to design our circuit in a Proteus. So to Arduino to make a program that will control those circuit. So here we have to connect 1 pins from LM that will connect to Arduino for the analog pin. The analog pin is the pins that is used to the component that will varying the analog signal. The reason why we take those pins you see on the LMs to the terminal A0 on Arduino, it is because the LM is the component in electronic that is varying analog signal from temperature. So let's start with our Arduino. First of all, I have to save our circuit. our circuit now is saved project. Yeah, let's go on the Arduino. We have a Arduino, so let's save as our Arduino. Let's take an library where we are going to save our Arduino code, and you come copy the name of our project and you comes to paste here and save our project. So we are going to start our Arduino program. First of all, we are going to declare our component. So int fun, like for example fun equal fun is on 8 I think, and int our lead is on 13, and val int val for the potentiometer I think is equal to 0. That will start on 0, or it is not important, or use int. We declare temperature values. We go temp value on A0. You remember we had take our LM35 that is connected to Arduino on the analog pins. You had seen to our design, and here you comes and first of all we make include for LCD library. Include you see, I think you know the library of LCD. Come on here, we write a liquid crystal dot h. I think we have a crystal.h. Yeah, I think we had that. It comes and int for our LCD like LS equal is on the pin is 12, enable is on 11 pin. On Arduino we have D4 equal like 5 pins, have a D5 equal on I think on 4 pins on our designer. D6 equal like 3 on our circuit, and D7 equal on 2 pins on our Arduino. Liquid crystal LCD RS enable D4 D5 D6 and D7 and you cross. Yeah, let me tell you that I think everybody that is attending this session, I think you know that this statement, the reason why we write this statement and the reason why we write this statement, those are all about the libraries of LCD. If you want to know every statement, and I will teach you how it works. So we continue. Void set up. I think you know. I think you know the structure of Arduino programming. Here you come here and the pin mode. Okay, we are going to directing our pins. On 8 we have output. Our 8 we have fan will be the output. Of course, when the temperature is high, our fan will start. You see, we come here and the A0, that is RM, connected to our Arduino analog pin. So here is input. It is an input because it is a sensor. We sense the temperature. Okay, come here, pin mode. On the LED is on 13, is output. Okay, yeah, you remember our question is here they tell us initialize the serial communication at initialize a serial communication at 19,200 baud rate. So we have to use for a serial communication. Come here to set up, write a serial dot begin, like paste, like 19,200 as a serial communication. So if you finish, you come to void loop Arduino program. Here we are going to start our code. Here we start to val. You know, we create a val. You see, that is equal the analog sorry analog grid A0 Yeah, you see, we write var equal analog read bracket a0. So this value will lead the values that will indicated by the pins from rm. That is, var is the variable declaration that will present and hold the values that we detected with lm. So we continue our codes. You come int int voltage equal var times or multiplication of 5,000 dot 0 over 1023. Okay, and you come int like Celsius equal voltage over 10.0 you see, and you come on serial print serial dot print serial dot print that we used to print any content you want to print on. You remember we had on our Proteus, we design a circuit, we put there, the virtual terminal. The way we use the virtual terminal and to print our content on a virtual terminal, you use a serial print. Come here, Celsius, our Celsius values equal, we use equal, that is our content will be displayed on our values of the temperature. I write a serial dot print. You see, we have to print the cell. Cell is a Celsius. You see here, this voltage is a voltage that will varying in Celsius. We use a voltage. Here we have a print our Celsius. You come here, we declare for our fans if we use a if condition, come on a bracket, if cell is a greater than 38. You remember we had a condition to our question to use if and only if temperature reached 38 degrees Celsius, our fans will work and will start. Let's see here, right, world Celsius, yes. On the body of our condition, write the digital write 8 for our fans high. Okay, yeah, is a high. Digital write for our ladies on 13, I think is a high. Yeah, is a high. This is our condition. If our Celsius is greater than 38, the fan will be high, will start, and the digital right on the 13th or is the where red is. Our red is, it will be on as indicator to show the person the temperature is high. Else, let's here we use else as when temperature is low. So use else. Okay, is a low, the fans will not working. Use the digital right, the here fan will not start. You see, is low. Okay, and you comes to digital right, I think we miss error. Yeah, digital on 13 as indicator red is low. Yeah, our code is a complete that we are not work on our display on a LCD. We verify our code, so we wait a little bit to verify our code like that. You see, okay, always a man have to handle the problem. And another, we verify again for another error. So you see, our program, there is no error. You come here and take a sketch our program. Remember, you come here and export compile binary. That is program will be sketched. That is means we have to upload our Arduino code to our Proteus. So you see, our sketch is be done. You comes to our code. So we come back on our void setup. We write about LCD dot begin like bracket the LCD dot like, for example, 40 and 2. You know, LCD dot begin 30 colon and 2. It means is dimensions of our LCD. Our LCD have 40 columns and 2 rows. I think it is clear. And you comes to LCD dot set cursor of course. LCD dot set cursor, I think I write cursor, yeah, like 0 and 0, like that. If you write lcd.setCursor example 0 0, let's we print our content to use lcd.print bracket, use double quotes, use our content. No, our content is called like, let's we comes to our notepad, take our content, come and paste to our lcd semicolon. You see our code, I think, is complete, so we can learn our temperature to our Proteus circuit. You have come here, export compiled binary. So our sketching is complete. So you come to our Proteus and simulate double port and put this, choose and OK, and you run to verify if our project is working. So automatically my project working because LM is on a 40. Let's we close our project and take our LMs, put on like, let's zooming, like, you see our LM is on a 44. You run our project, you see our fan is not running and our red is not turned on. If we want to, let's say variating our LM to 38, let's we see. So here we have 36, 37, 38, 39. You see, let's we see. You see our red turn it on and our fans is running. You see, is in rotating. You see our fan is rotating. So you see our values not printed on our LCD and not displayed on our virtual terminal. Let's we start to handle our problems in our code. Use like 90,000 and 600 as a serial.begin and yeah, come and save and sketch our Arduino code. Yeah, our sketch is and you comes to our Arduino and you put our sketch, okay, and you run. Yeah, you see our Celsius is they are showing our Celsius, but we have to change. Those is printed on one line, but we have to make a new line and you have to print a Celsius on LCD here. So let's we take our time to handle those problem. So we comes again to our Arduino, and we make a print line like that, print line, and here line. You come here to serial, LCD dot begin, like that, and you want to print the temperature. Yes, we need to use temp. No. Temp equal like that. You come write LCD dot set cursor, right? Is it like that? Yeah, LCD dot begin bracket. It will set on 1 like 1 okay, and write temp values, okay, and write cell. Yeah, I think it's complete. That is those code we learning well. Let's we close our code, and here you close, and we want to sketch. Let's we sketch our code, and we verify if the something we made are okay. There is another problem. LCD dot begin, no, it is not begin, it is a print. Serial dot print is a print. Here is a set cursor, yeah, and you sketch again. Yeah, our code is complete. You comes to Arduino, and you come to Arduino Uno, and choose a standard again, okay, and you run. Wait, yeah, you see our Celsius is equal to 90 and 39 in our terminal, and our temperature is displayed here, content, and the temp value is displayed here. Yeah, you see, if you vary it, our RM, yeah, you see our temperature is increased, and you see on here is increased, and again we add on to when take a 45 example, you see our Celsius here is 44, and here we have a 44 and 45 and 45. So you see our design is working well. Let's me show another again. We start when our Celsius on 35. So we take our RM on 35, okay, our RM is on 35. We run again. You see, our temperature is on our 35 and EC is 35. You see, a virtual terminal, our virtual terminals, we running our 35 and our LCD display 35, terminal 35 and the LCD 35. We are going to increase our temperature by using tempo values. You come here and increase, then it comes 36, you increase, then it comes 37, you increase, then it comes on 38. 38, our code on Arduino, we use the condition if Celsius is a greater than 38, the LED and the fans will start. The LED will turn on and the fans will start because we use the greater than 38. When we use a Celsius greater than or equal 38, the Proteus was started because was not started because we use a greater than. We do not start and red is not turn on because we use a greater than 38. Let's we add one, so becomes a 39. Then our circuit and fans starts and red turn on. Let's we add on 1. You see, we have 38. 38, the LED indicated turned on, and the fan, you see, the fans start to rotate. So thank you.